Hi everyone, welcome to the Earth Science Regions Review podcast series created by Hammock's Middle School Earth Science Department. Today we're going to be talking about page 15 in the reference table, your solar system data chart. Now this chart is relatively easy to read because everything's in nice neat columns and rows. So let's start all the way to the left hand side. These are the objects that are up in space. This is basically our solar system, our 8 planets, our sun, and including our moon. Next section is how far away these objects are from the sun. And as you can see here, as you progressively get further and further through the planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, the distance gradually gets greater and greater. And those units are in millions of kilometers. The next section over is going to be how long it takes for these objects to move around the sun or revolve around the sun. This is basically going to be the year. Now this is Kepler's third law, which basically states the farther an object is away from the sun, the longer it's going to take to revolve. Now Mercury revolves once every 88 days. Neptune revolves once every 164.8 years. Okay, so very important to understand that relationship in regards to our planets. The next section over is how long it takes a planet to rotate on its axis, or basically how long it takes for a day to occur on that specific planet. And if you notice, the one oddball in this case is going to be Venus. Venus's day is actually longer than its year. Next is going to be your eccentricity. Okay, basically, when you have an eccentricity that is close to 1, its orbit is going to be very flattened. If it's close to 0, it's going to be very round. Next is going to be the equatorial diameter. Okay, this is basically going to give you a relative size in how big or how small the planets are. You notice that Mercury, Venus, Earth, and Mars, your terrestrial planets, are quite small. Jupiter, Saturn, Uranus, Neptune, your Jovian planets, are quite large. Next is mass. We've given Earth a relative mass of 1. Anything that has a value less than 1 means that that planet is smaller than Earth. Any value that's bigger than 1 tells us that the planet is bigger than Earth. You see that Jupiter is going to be the biggest planet in our solar system. Next is going to be density. And this basically shows us that the terrestrial planets are going to be a little bit more dense, Mercury, Venus, Earth, and Mars, than your Jovian planets of Jupiter, Saturn, Uranus, and Neptune. The one oddball here is going to be Saturn, that has a density of 0.7, means that Saturn would float in the water. Okay, so let's just show you just how this is going to work. If we wanted to figure out Mercury's eccentricity, okay, Mercury actually is actually the most eccentric orbit in the solar system at 0.206. You compare that with Venus's eccentricity, which is going to be the roundest at 0.007. Next, if we have Saturn and we want to know Saturn's equatorial diameter, in this case it could be 120,536 kilometers. We want to know about Mars, okay, period of revolution, that's going to turn out to be about 687 days. Okay, and with that being said, good luck with your preparation, and we'll talk to you soon. Bye-bye.